Lesson 2.5 kind of adds a little bit of complexity to this unit. I'm kind of hoping that what we've done so far seems kind of easy and like review, but this is when that kind of changes, and we got to talk about a new big idea sort of thing. So compound inequalities are inequalities formed by joining two or more, oftentimes just two. Two or more inequalities with the word and or. Okay, so and means all, usually just both, usually just two. All the inequalities must be true. Must be true for us to have a solution. Or means at least one of the inequalities must be true. So it's easier to meet the requirements of an or inequality because only one of them has to be true. An and inequality, they all must be true at the same time. So an and inequality, if I were to draw two inequalities on the same number line, an and inequality is where the two cross over. So oftentimes we'll see an and inequality where one goes to the left towards the other starting point and the other goes to the right. This stuff in the middle is part of the answer, but nothing further to the left and nothing further to the right. So and inequalities are always going to point towards each other, or inequalities we should expect to point away from each other. So basically what this means is we can have anything except for the middle. So an and inequality will often say we only want the numbers in this range. An or inequality is we want anything except for the numbers in this range. So an example for anything except for the numbers in this range is if you're fishing and you've got, a certain size that you're not allowed to take because that size is like, maybe a 16 to 20 inch bass. Maybe they're oftentimes pregnant females. And so if I change this to 16 to 20, I can take home and cook up anything I find that's not within that range, because this range is what we want to keep in the lake or the river or whatever to keep the cycle going. This one over here is easier to come up with an example for. We want this range. There's roller coasters where if you're too short, it's not safe. And if you're too tall, you might bonk your head on a bar, which clearly isn't safe when you're going 60 miles per hour. So we would only have people in this range. So maybe you have to be between 5 feet tall and 6'8". That's pretty tall, right? So an and inequality, inside. An or inequality, anything except for the inside. So those words are actually pretty important here. The specific word and the specific word or have now kind of become math terms for us. So real quick example, and this is just a translating one. A number y, that's the variable we're comparing with, is at most 0 or at least 2. So when we write out this inequality, I want to write out two separate inequalities with the word or in between. Sorry, I keep knocking the camera. So y is at most 0. At most 0, it can be less than, and it can be equal to, but it can't be greater. So that should be the less than or equal to sign. Y is smaller than or equal to 0, or at least 2. Y can be bigger than or equal to 2. So this is the compound inequality. Now with or, this is really the only way to write it. With and inequalities, there's a second way we can write it. And so when we get to an example like that, Now I'll talk through it. That should be next, actually. I forgot to graph the last one for you, but I won't forget on this one. A number x is greater than -8 and less than or equal to 4. So I'm going to write the word and, but I'll also have a second way of writing and inequalities. X is greater than -8. X is greater than -8. Can't be equal to because it specifically wants greater than. And x is less than or equal to 4. So it can be smaller than or equal to 4. Okay. So when you have an and inequality, what I can actually do is put x in the middle, and it's going to be bigger than something and smaller than something. It's bigger than -8, and it's smaller than 4. This is another way of writing an and inequality. I like this. I also like this. Sometimes they'll give you this. Sometimes they'll give you this. But if you ever see this, this is only for and only. That's super important to remember. Let's actually graph this one. Try not to forget like the last one. So I need to go all the way from -8 to +4. And I'm just going to do that. I don't need all this stuff in the middle. Whatever, right? We know where the boundaries are. So it's an open circle at -8 because there's no line underneath for that comparison. And it's a closed circle at 4 because there is a line underneath for that one. Now x is bigger than -8, so this one goes that way. And x is smaller than 4. This one goes to the left. And this forms what we discussed in and inequality should look like. Shades in the middle. Or should shade in opposite directions for it to make sense. And should shade in the middle. Now for an Algebra 1 class, that's factual. Me, honestly, this lesson is probably something in math, besides simple algebra solving skills, that I use more than anything else because I'm a programmer. This kind of stuff shows up way more often than any of you think, and we literally have to use the words and or in between all our inequalities. So this is real. This is valuable stuff that you could put to use if you chose to give something a try. First example of solving one of these equations. So this is an and inequality. We should be able to tell by the way it's written to begin with. So there's two ways we can do this. One is solving separately. So each inequality symbol can kind of be thought of as making its own separate inequality. So I'm plucking it apart, and the middle is a thing that's in both. So what I have here, written in green, is technically the same as what's in purple, just written in a different way. So now I can just do my algebra steps. I'm going to keep that word and in every step. Add 2 in this one as well. Keep forgetting to cross out my numbers. And this is my solution. So graphing that, I would need to be bigger than -2 and smaller than 5. Both would be open circles. Bigger than -2 is this way. Smaller than 5 is this way. And just like we expect an and inequality to do, it meets in the middle. So the next one is going to be solving it straight from here. This might be a little bit quicker than the other way, but honestly, I'd prefer you to break it apart when you solve them. There's going to be situations where solving it like this doesn't work. And that's really because occasionally there's going to be variables on one of the far ends too. It's weird, but it's possible. But we can solve it just from here. If we treat this like there's 3 sides, and every time we do an algebra step, it has to happen on all 3 sides, then we can solve it straight from the bigger compound inequality without splitting it up. So it's technically less work to show, but there's times this doesn't work. And hey, look at this. I'm dividing by a negative number. You know what that means. It's still true here. Flip. So I've got 2 greater than symbol, x greater than or equal to -4. can still graph that. Flipping didn't mess anything up. In fact, flipping was necessary for our answer. We should still get it to go in between because it was an and inequality. So I'm comparing to -4 and 2. The -4 had a closed circle because it had an or equal to. The 2 has an open circle because it's just less than. And then greater than -4 goes to the right, smaller than 2 goes to the left. And just like we expect with and inequalities, they meet in the middle. So again, I'd prefer we actually split it apart like I did in the last example, but this is technically less work to show. I'm comfortable with you using this unless there's variables on the outsides. All right, but there's nothing wrong with either method. It's just this one gets a little bit tricky when there's more variables on more sides. In an OR inequality, there is no solving together. It's always going to be separate like this. So really, we are just solving two inequalities like normal in one problem. That's really all the more complicated it gets. Yeah, we graph at the end, but just treat this like we're solving two separate problems, so normal algebra steps. If we got to flip, we have to flip, but I don't think this problem's going to make us. There's the first inequality. Let's see what the second one's going to be. Add 1 on both sides. 2y greater than 6, divide by 2. Y greater than 3. So I don't really talk through this one too much because there's not really much to talk about. It's just solving separately. So now when we graph them, because it's an OR inequality, we should expect them to go away from each other. So I have -1, and I've got +3. They're both open circles because neither of them has an or equal to, and I'm smaller than -1, bigger than 3, and that's my answer and my graph. So just solve separately. OR should never be done together or cannot be written together. So OR is always going to look like this. And is the one where we can have that separate combined special notation. We'll do the modeling problem together for this lesson, but just know that the new types of word problems, what we're looking for is an and or an or. So and is when we have a range we want. So like the people riding the roller coaster, we don't want to be too short, we don't want to be too tall. So there's a happy middle area. And or is a range we don't want. Okay, so there's going to be some middle values we don't want. So we can be, well, the fish example is the best one I can think of. Other examples are, oh gosh, I'm trying to think. There's not a lot of great examples for when to use OR inequalities rather than just using AND. Because if you want an OR inequality, if you want things that are separate, you could just make it opposite and say AND. That fish example is just a good one, where you want to keep the fish that might be pregnant in the river or the lake so that they can continue, making more fish. And so you'll take anything except for that range that's most often like the pregnant female fish. So that's really just a good example for this. And is when we want the middle stuff, or is when we want to avoid the middle stuff and take everything else in either direction. So this is really what the word problems look like. And I'd say most of the time, and is the more appropriate word problem. This is the one I'd say we come across most often. The modeling problem on here wants us to represent the possible operating temperatures. That's an and inequality. So like for a phone, you don't want it to be too cold or too hot. You could rewrite that as an or inequality and ask the question, when would it fail? But normally we want to know what we want, not what we don't want. I don't know. That's really the difference between these. What we want versus what we don't want. Normally we talk about the acceptable things rather than specifying the unacceptable things. So there's always exceptions to that, but those are kind of the purposes of these two words. And that's it for the lesson. It's something I'm guessing is new to you guys, but still relies on the same algebra skills. The big vocabulary is the math meaning of the words and or.